Everybody, in this video I'm going to walk you through the wheel subassembly for the T9 Automoblox. This is probably for the IED course if you're in Project Lead the Way. So we have the three parts here. We have the axle, we have the wheel, we have the tire, and our job now is to assemble these together. And up until this point in the curriculum, at least if you're in my class, all you've done is the puzzle cube project. So you use mate and you use flush in order to constrain. Up here with this constraint menu, right? You use the mate and the flush. But the problem is, you know, those were flat surfaces that we were joining together. And flat surfaces are one thing, but curved surfaces are another. How do we get these things together? Okay. Well, this constraint menu is actually a lot deeper than you probably realize. We have all different kinds of constraints up here. And the type of constraint that we typically use for circular objects, for round objects like wheels and axles and tires, okay, all circles, would be the insert constraint. The insert constraint is super easy if you know how to do it, okay? So I've just clicked on that. I've clicked on constraint and then here. And what I'm going to do is I'm going to click first on this edge of the axle. And the reason I'm choosing that edge as opposed to, say, this one or that one or this one here or this one is because wherever I click, well, that's how far in the axle is going to go into the wheel. So I'm choosing like the boundary of how far I want to push this object into a different object, okay? So I'm going to click here. Notice that was a red circle, right? Because now I'm going to go and I'm going to click on similar situation over here in the wheel, okay? Notice it creates a red circle. And when I click on the wheel right here, it's going to make those two red circles, the one from the axle and the one from the wheel. It's going to make them line up on top of each other so they're at the same boundary, okay? And so when I click here, you'll notice then, how about that? It's done, okay? The wheel is absolutely done. So that's how easy the insert constraint is. With one click, we can get that thing fully constrained in place. Even cooler now, as we notice that the wheel actually spins. So that's pretty sweet, right? And we're ready to go add the tire. So let's do the same thing, and I'm going to point out an error, a common error that happens here. Okay, when I do the constraint command, and I'm going to use an insert constraint because it's a circular object. Okay, I'm going to first choose the outer rim of the wheel. Notice not the inner rim, not this one, but the outer rim of the wheel. And then I'm going to come over here. I'm going to choose this circle because I want it to line up on top, right? And this is the point where kids that are new to this haven't used it before, and this is okay. I mean, but they go, wait a second, I must have screwed something up. So they cancel out of it and they try it again and they click on different circles over and over again until they get it correct. I want you to understand, just like the mate and the flush would flip the object around, this will do the same thing. Insert, I have this option here for opposed, but I also have aligned. And if you don't like one way, try the other, okay? And you're going to notice then, like in this case, I just needed to choose the other option for aligned, and when I do that, now the wheel is good, right? So that's pretty cool. We have the wheel and the tire now assembled together. We do have an issue though, and the issue goes like this. See, when I spin the wheel, the tire doesn't spin. And when I spin the tire, the wheel doesn't spin. And we know that those should probably spin at the same rate, shouldn't they? So how can we get these two objects to move together? Okay? And so the fix for that is as such, okay? You'll notice over here we have an origin menu, just like we've talked about with building stuff beforehand. And if I expand it, you'll see that the origin menu is actually related to the assembly itself. But then each part also has its own origin menu. So for instance, the wheel has its own origin menu, and what it means is that when you originally built the wheel as an IPT file, here are the X, Y, and Z planes that we used while building. Furthermore, one like this one, if I right click and I make it visible, you'll notice that that work plane that's connected to the wheel cuts right through the middle of it, okay? That's pretty important because now when the wheel turns, the plane turns with it, okay? It's the wheel's work plane. Notice when I turn the tire, nothing happens. Well, the tire has its own origin menu too, and if I go and expand the origin menu for it, same deal, right? I got a couple of work planes that cut right through the middle of that tire, so I'm going to go and I'm going to make one of them visible. Don't care which one. Now this new work plane that I just made visible moves with the tire but not with the wheel, okay? See? One plane for the wheel, one plane for the tire. The reason that that's important is because now I can do this. We have a second kind of constraint. We already did the insert constraint to get them to line up on top of each other. Now we're going to use what's called the angle constraint. The angle constraint has three different options, and it defaults to the explicit reference vector option right off the bat. You don't know what that means. I don't know what that means. Let's not use that one. Let's use the one that has two objects here. It's called the directed angle constraint. That's the one we're going to use for 99.99% of our stuff in IED. Okay? And what the angle constraint does is it says if I have two objects, if I pick any two surfaces out, that it can lock it together so that the angle between those surfaces is 0 degrees. So now maybe you're wondering, why did I put those work planes on? Well, because now I can go through and I can say, you know what, the angle between the surface here and the surface here needs to remain at 0 degrees at all times. And now when I click OK, when I spin the wheel, the work planes are locked together, so the tire has to spin as well. Your wheel is now fully assembled, everything is good to go, and you're ready to go put it on the car. Even better, if you save this as its own wheel subassembly file, which is what I've done, if you click save, you're going to notice it says wheel subassembly. Even better is now, if I go into the regular car assembly for the T9 Automoblox, I can actually place the entire subassembly in one click, fully constrained, and I don't have to go through this process for each of the 4 locations where the wheels are located. One last thing that you might want to do before we quit this video, now that you're done with those XY planes, we might want to go through, click here, choose visibility, click on this one, and choose visibility, just to get rid of those so we don't have to look at them anymore. Hopefully that helped you. There's the wheel subassembly along with the insert and angle constraints and how you can use those for circular objects. Also will be very helpful for the train project later on.